Solving one-step inequalities in one variable. Start with a definition. An inequality is a mathematical statement comparing quantities that are not equal. And there are a lot of symbols that we need to be familiar with. This is the not equal sign. Greater than looks like this. Greater than or equal to. Less than and less than or equal to. So we're going to use these symbols in connection with an algebraic inequality and ask you to graph those inequalities on a number line. X is greater than 4. We're going to start with an open circle at 4, and we want numbers greater than 4. So 5, 6, 7, etc. Notice we are not coloring in 4 because we want numbers strictly greater than 4. The next example, we'll start with a circle that is filled in at -5. And I like to read this inequality as y is greater than or equal to -5. So I start at my variable and read that way. So I want to go everything to the right of -5. Now, in the next example, some people read this as 1 is greater than or equal to n. In any event, we start with a closed circle at 1. Personally, I read it like n is less than or equal to 1, so I want everything to the left. And in the last example, let's put a closed circle at -3.5. It's saying we want to graph numbers that are less than -3.5. All right, next example, we're going to switch it up. I'm going to give you the graph. You're going to come up with the inequality. So example A, I have an open circle at -1, and I'm shading everything to the right. And you can pick any variable you want. So k is greater than -1. Example B, we have a closed circle at 25, and it's everything greater than or equal to 25. Example C is an open circle with everything shaded to the left. So let's do R is less than 3/4. Example D, we have a closed circle and we're shading everything less than that 150. So Z is less than or equal to 150. Notice when there's an equal to sign attached to the inequality, we have a closed circle. It's colored in. But if it's a strictly less than or greater than inequality, it is an open circle at that value. Okay, so we can solve inequalities just like we solved equations. I'm going to recommend we use the strategy of isolating the variable. So let's, for the first example, x minus 3 is greater than or equal to 5. Let's add 3 to both sides. Rewriting our inequality, I now want to graph this x is greater than or equal to 8. Let's put 8 in the middle of a number line and 7 to the left and 9 to the right. We need a closed circle, and we are shading to the right because we want numbers that are bigger than 8. In the second example, let's subtract 2 from both sides, and we want 1 in the middle of the number line, 0 and 2 surrounding it. Do you see we want an open circle at 1? And I want numbers greater than 1, so I want to shade toward the 2. What if I were solving inequalities with multiplication and division? A really good strategy when you're multiplying by a fraction, like the first example, if I multiply the whole equation by 2, then I've isolated my x. So I get 2 times a half, which is 1, right? X is less than or equal to 16. On my number line, we'll have 16 in the middle. And this time, let's skip count by 2. We want a closed circle at 16, and it's less than, so let's shade toward the 14. And we could check that we've done that correctly. 14 is in the solution set. So if I substitute 14 in place of x in my original inequality, let's do a half of 14, right? That's 7, which is less than or equal to 8. All right, the next example is we want you to pay special attention because to isolate x, we have to multiply by a negative 5. Whenever we multiply or divide an inequality by a negative, we switch the direction of the inequality. And so we want negative 25 in the center. We can skip count by 5s. Open circle at negative 25, and we're shading everything greater than that, so to the right. And again, you could test like negative 20 to make sure that it's in the solution region. Let's plug negative 20 into the original inequality. The opposite of x, right? So the opposite of negative 20 divided by 5. All right, what's that? The opposite of negative 20 is 20. 20 divided by 5 is 4, which is indeed less than 5. Finally, we have a word problem. An airline allows a suitcase that weighs no more than 50 pounds when it is full. Jared's empty suitcase weighs 5 pounds. How much weight can Jared pack in his suitcase? Write an inequality to solve the problem and graph your solution. So first of all, we understand that his suitcase weighs 5 pounds. The amount of weight he can add we'll call x. So x plus 5 has to be less than or equal to 50. We're going to solve this inequality and graph it. So anything less than 45 or equal to 45, of course, you can't have less than 0 weight also. So understand our arrow would end at 0. Would work in this problem. And this one says an employment agency charges a company 15% of the salary for every position filled. What salary must a company pay a new employee for the employment agency to earn a commission of at least $6,000? Okay, so we want 15% of the salary. 15% is 0.15 times x. We'll call the salary x. We want it to be at least $6,000. So $6,000 or something more than $6,000. Now let's divide by 0.15, and at this point using a calculator is fine. So we get x has to be greater than or equal to $40,000. That's the salary that the company must pay a new employee for the employment agency to earn their commission of $6,000 or more. We're going to graph this. 40,000 will be in the middle. It'll be a closed circle. And I want to shade everything to the right of $40,000.